Hey, welcome to my technical sound design showreel. My name is Mads, and I'm going to talk a little bit about two projects that I worked on. The first one is my bachelor thesis about game audio pipeline development. The thesis is a study of the importance of game audio pipelines and how to create a pipeline that streamlines and optimizes workflow and game audio implementation. It is an examination of the various elements that goes into pipeline development and the considerations to take into account. This information is then exemplified in a case study of a third-person adventure game. The game is treated as a prototype in pre-production and aims to showcase how a pipeline could be designed. The case study includes various custom tools for workflow and implementation. The thesis is based primarily upon interviews with various game audio directors and game audio professionals. Among the pipeline and implementation tools designed for the prototype, it's worth mentioning the Wwise type system. The system is taking advantage of the Wwise types classes and reduces the amount of communication and information needed between the sound designer and the programmer. The programmer only needs to implement the appropriate Wwise type function at the point of execution in code, and the sound designer is able to decide the behavior, like action type, interpolation, fade, and audio emitter directly in the inspector. This is a great tool for easy implementation and iteration, especially on smaller projects. Sound Painter. The Sound Painter tool makes the process of freehand implementing multi-positions way easier and much more fun. The Sound Painter is basically taking the already existing multi-position system and putting it into a much more user-friendly interface. No more dragging positions around or getting caught by the AK ambient position bug. Many other tools was designed during the development of the thesis, and recently the thesis got published as an article on the website A Sound Effect. The second project I want to showcase is my dynamic reflection system. The idea is to create a lightweight system which takes into considerations how acoustics works in real life. It currently consists of three parts: a reverb calculator, an early reflection system, a material reflection system. The system is constantly shooting rays vertically and horizontally around the player and keeping track of the distance to each surface around the player, the area of each surface, the type of material for each surface, the absorption coefficient of each surface, the volume of the room the player is in, and much more. All this data is then processed and used for various calculations. The reverb is determined using the Sabin metric calculations and works in three different frequency bands: low frequency absorption, middle frequency absorption, and high frequency absorption. The early reflection and material reflection system is using the distance to each surface to determine whether or not the player should hear early reflections. When the player shoots his gun, the system goes through every possible hit points and determines if they are in range. The hit points are then used as custom listener objects and as 3D positioned aux channels at the same time. This way we can make a callback system. We route the gun sound to 4 different game-defined 3D positioned aux buses, but we only use one of the 4 direct game-defined aux buses available on the gun. For the material reflection, we access the surface material of each hit point. We use this information to drive a switch, which determines what type of material reflection we should emit from the hit point. The result is a dynamic system that gives a whole different spatial experience compared to regular collider-based reverb setups. The dynamic reverb tells us something about the size and type of location we're in. The early reflections tells us about the distance to the walls, and the material reflections tells us what material the location is made of. When we stand in the corner of a metal shack, it should also sound like we're standing in the corner of a metal shack. Potentially, this system could save tons of man-hours, and it could be a great tool for procedural generated games and levels. The system is still work in progress, and in the future it is hopefully going to include various other parameters, like occlusion, obstruction, slapback, indoor-outdoor calculations, and much more. Thank you for watching my showreel all the way to the end. You can find links to the mentioned projects in the description. Feel free to contact me or visit my webpage to see more of the work I've done.